Jai Hind students, welcome to my YouTube channel. Students, as I've always maintained, never ever quit. Quitting won't make the challenges go away. Instead, the only way to truly handle our challenges is by facing them head on. And that requires a powerful, pure burning motivation to take action despite these setbacks. So students, it is important to have at hand some encouraging quotes or a few uplifting quotes. You might underestimate their effect, but reading some can do magic for your current situation. They actually work like a pill that will help you get back on track and face your challenges with new energy, new passion, new determination. And this is the very reason why I always tend to start my lecture with a motivational or an inspirational quote, right? So with that students, let's start today's session. In the previous lecture, we have discussed about inertial and non-inertial frames of reference, isn't it? So this session is devoted to the numericals based on non-inertial frame of reference, where a pseudo or a fictitious force comes into existence, right? So let's start with the first question then. A block of mass m is placed on a smooth inclined plane of inclination theta with the horizontal. Let us represent it with the help of a diagram. This is an inclined plane, make an angle theta with the horizontal, and this is the block placed over here, right? The whole system is accelerated horizontally so that the block does not slip on the inclined plane. Calculate the magnitude of the force exerted by the plane on the block. Read the statement, students. Force exerted by the plane on the block. Force exerted by the inclined plane on the block. That is, we are supposed to find out the reaction force. This is our objective. Reaction force is the force exerted by the inclined plane on the block which is placed over it, right? So, in order that this block kept on the inclined plane do not slip, the entire system must be accelerated along this direction. Say, with acceleration A. Right, students? Suppose it is the entire system is accelerated with acceleration A along this direction. So, as a result, if the mass of the block is m, then we are aware it will experience a force m into A, that is in a direction opposite to that in which the entire system is accelerated. So it will experience a force along this direction. This is ma. This is the fictitious or the pseudo force that we have discussed in the previous lecture, right? I will provide you the link of that previous theoretical lecture in the description section of this current lecture. So, again I repeat, this is an accelerated system. So this is a non-inertial frame of reference. So fictitious force will come into play. So this block will experience force if the mass multiplied by the acceleration with which the system gets accelerated in a direction opposite to which the system is accelerated, right? So this is the fictitious force. What are the other forces acting over here? Weight, mg, which will act in the downward direction. The reaction force, which is to be found. This always acts normal, that is perpendicular to the surface over which the body is placed, right? And it's given to be smooth surface, so force of friction is negligible. Okay, now what to do is, let us resolve MA into two components. If this is theta, this would be also theta, pair of corresponding angles. So this component would be MA cos theta, while the other perpendicular component opposite to the reaction force, it would be MA sin theta. Am I clear, students? Similarly, the weight mg of the block, it can be also resolved into two perpendicular components, right? So this angle is also theta. So this component would be mg cos theta, and this component, it would be equal to mg sin theta. Now this is the complete diagram along with all the forces acting on this block, right? Now this block is to remain at rest with respect to the block. It shouldn't slip. So it means that the net force acting on this block must be 0. It means that the block must be under the influence of balanced forces, and that is feasible only when R is equal to mg cos theta plus ma sin theta. So net force acting along this direction is 0. So net force R along this direction must be balanced by the net force acting in the direction opposite to R, which is mg cos theta plus ma sin theta. Put this as equation 1. Also, mg sin theta must be exactly balanced by ma cos theta, right? Also, ma cos theta, it must be equal to mg sin theta. Now, using these two equations, we are supposed to get the expression for the normal reaction. Look, friends, we are supposed to find out the force exerted by the inclined plane on the block. So, we are supposed to find out the normal reaction, right? So, A is not given in the quotient, so A needs to be eliminated. So, what we'll do is M get cancelled. So, A would be equal to G sin theta by cos theta is tan theta. Now, from equation 1 to 3, substitute this value of A over here. So, from 1 and 3, what we get is normal reaction R is equal to mg cos theta plus m sin theta multiplied by A. A is G tan theta, right? So, let's try to evaluate it. Mg can be taken as common. Over here, it's cos theta plus mg has already been taken as common. Tan is sine by cos, so it will become sine square theta divided by cos theta. Students, it can be further evaluated, right? Taking LCM, what we get is cos theta, and in the numerator we'll be having cos square theta plus sine square theta. Now we are aware cos square theta plus sine square theta is unity, that is 1. So what we get is mg divided by cos theta, or the reaction force, which is the force exerted by the inclined plane on the block, is mg 1 by cos theta is secant theta. So this is the answer, students. This is the force exerted by the inclined plane on the block, which is the reaction force, right? So I hope you have understood this concept. So whenever the system gets accelerated, any body which is on this system, it will experience a force in the opposite direction, and the force would be equal to the product of mass of that body multiplied by the acceleration with which the system is accelerated. Clear? So we are over with question number 1. Let's try to concentrate on question number 2 then. Question 2 is a very, very good and interesting question actually. Okay, question 2 is, the rear side of a truck is open and a box of 40 kg mass is placed 5 meters away from the open end. Okay, and the coefficient of friction, this is coefficient of friction between the block and the floor of the truck. On a straight road, the truck starts from rest and accelerates with 2 meters per second square. At what distance from the starting point does the box fall off the truck? And we are supposed to take the value of small g as 10 meters per second square. Okay, let us try to evaluate it. This is a very, very good question. Okay, this is the situation basically. Suppose this is a road and this is a truck under consideration. This is suppose the truck. Okay, this is the truck and this is the rear side of the truck and a block is kept over here. Suppose its mass is smaller and the truck is initially at rest and it is accelerating with an acceleration of 2 meters per second square. Right? So truck is accelerating. So it must be a non-inertial frame of reference. So this block must be experiencing a pseudo force in a direction opposite to which the system gets accelerated. Right? So it must experience a force along this direction. M into A. This is the pseudo force. The system is accelerating along this direction. So this body on the system will experience a force, mass multiplied by A in the opposite direction. So that's the concept of fictitious or the pseudo force. Right? And it is given that coefficient of friction between these two surfaces in contact, it is given to be 0.15. It is given to be 0.15. Right? And the mass of the box is given to be 40 kg. And it is placed 5 meters away from the open end. This distance is given to be 5 meters. So we are supposed to find out what distance from the starting point does the box fall off the truck. As it moves forward, the box will tend to come along this direction due to this fictitious force, right? Provided it is greater than that of the frictional force. So we'll see. So let us draw the diagram, representing all the forces acting on this block. So let's draw the free body diagram. So this block will experience a pseudo force Ma along this direction. Its weight will act in the downward direction. Normal reaction will be in the vertically upward direction, normal to the surface, perpendicular to the surface, and the body will tend to move along this direction. So it will experience a frictional force in the opposite direction. Right? So R will balance mg, no doubt regarding this. In the vertical direction, the body is under the influence of balanced forces. So R would be equal to mg. Right? Let's calculate Ma. So magnitude of this pseudo force is M into A, which is mass is 40 and acceleration is 2. So it is 80 Newton, isn't it? Now, magnitude of frictional force. It is small f, and we are aware it's equal to mu r. It is equal to mu into m into. So the frictional force will be given by the value of mu, that is the coefficient of friction between these two surfaces in contact, is given to be 0.15. Mass of the block is given to be 40. G is 10. So what we get is 15 into 400 divided by 100. So we'll get 60 Newton. Right? So students, look. This fictitious force, it is greater than that of force of friction. So definitely the body will have an acceleration along this direction. Isn't it? It will have an acceleration along this direction. And this acceleration of the block would be different from the acceleration with which this system, that is, the truck, is accelerating. Clear? In case the force of friction is greater than Ma, then the block would never fall off the truck. Clear? And in case F is equal to Ma, then the block will remain at its original position, in spite of the fact that the truck starts accelerating in the forward direction. But here, in the present question, force of friction is less than the pseudo force, that is Ma. So block, as the truck accelerates in the forward direction, the block will accelerate in the opposite direction. And after the truck has covered some distance, definitely the block will fall off the truck. And we are supposed to find out that distance from the starting point at which the box fall off the truck. So that distance covered by the truck is to be found. Right? So here it's pretty clear. Ma is greater than F. Therefore, what will be the equation? R is balancing mg. So what will be the equation? Ma being greater than F. Therefore, net force is Ma minus F. This is the net force acting on the block, right? And as per Newton's second law, net force acting on the block is mass into acceleration. Its mass is m and acceleration of the block is a dash. Therefore, ma, we have found its magnitude, it is 80 minus frictional force, its magnitude is 60. It is equal to 40 into a dash. Clear, students? So, a dash is equal to 20 by 40. So, it is equal to half meter per second square. So, truck is accelerating with 2 meter per second square. But the block will accelerate in the opposite direction with an acceleration of 0.5 or half meter per second square. Right? Okay, this we have calculated. Now let us find out the time which the block will take so as to fall off the truck. After what time the block will fall off the truck? So let's try to evaluate that time. Okay, for the block, its acceleration is half meter per second square. Right, students? And the distance before it falls off the truck is 5 meter. Initially, the block is at rest. So we can make use of second equation of motion, S equals to ut plus half at square, isn't it? So the distance which the block needs to cover so as to fall off the truck is 5 meter. So it is 5. Initially the block is at rest, so this term gets eliminated. Half into A is half and t square. So students, t square is equal to 20 or t is equal to square root of 20 seconds. So after square root of 20 seconds, the block will fall off the truck. So this is the time. And our question is, during this time, obviously the truck would have covered some distance in the forward direction. So our objective is to find out that distance covered by the truck, after which the block placed on the truck will fall off from it. Right? So now let's for the truck. Let's consider the equation for the truck. For the truck, again, initial velocity is 0. What is the acceleration of the truck? It is 2 meter per second square. We are supposed to find out the distance covered by the truck in the time root 20 seconds. Clear? So, again, let's make use of second equation of motion, which is the displacement time relationship, S equals to ut plus half at square. So what I get is ut will become 0, half acceleration. Remember, this is the acceleration of the truck, which is 2. T square, it is 20. So what do you get? S is equal to 20 meters. So students, this is the answer. So the truck must have moved 20 meters before the block kept on its rear end will tend to fall off from it. So this is the answer, right? 20 meters. So this was indeed a very, very good question. So we are over with question number 2. Let's proceed with the next question then. Let's start with question number 3. Now concentrate on the diagram, students. This is a cart given and it is accelerating from left to right, and the acceleration is given to be alpha, and this block of mass m is also provided, and the coefficient of static friction between the block and the cart C, between these two surfaces, is given to be mu. We are supposed to find out the acceleration alpha of the cart that will prevent the block from falling. We are supposed to find out the condition. So we are supposed to find out the expression for alpha so that m, block of mass small m, doesn't fall. Right? So this is again a very, very good question. Okay, let's try to find out. Let's draw the free body diagram of block M. This is block M. Now, the entire system is accelerating along this direction. So obviously again it is the case of non-inertial frame of reference. So the body which is constituting the system, it will experience a pseudo force. It will experience a force in the opposite direction. This block will experience a force in the opposite direction. And what is the magnitude of that force? Mass of the block multiplied by acceleration with which the system is accelerating. So this is the force. So this is M alpha. Now this is in contact with this. M alpha is the force exerted by the block on the cart. As per action reaction concept, the cart will exert an equal and opposite force on the block. So this will be the normal reaction. This will be the normal reaction, right? And its weight, it will act in the downward direction. Now, it will tend to slip, it will tend to fall. So force of friction will act in the opposite direction, isn't it? This is the weight, mg, and this will be the force of friction. This is the force of friction. Now students, look, for the block, if we want to prevent the block from slipping or from falling down, it must be under the influence of balanced forces, right? So F must be equal to mg, or rather we can say F must be greater than or equal to mg. Force of friction must be greater than that of the weight of the block. It is only then that we can prevent the block from falling down, right? Also, F is equal to mu r, we are aware of it, and R is equal to m alpha, right? So make use of these three equations. What we get is, in place of F we can write mu r is greater than or equal to mg, or mu r is m alpha is greater than or equal to mg. M get cancelled. So alpha, it must be greater than or equal to g by mu. This is the condition which, if satisfied, it will prevent this block from falling down, right? This must be the minimum acceleration with which the entire system must be accelerated. So this was again a very, very good question based on the concept of fictitious force, right? So whenever the system is accelerated along this direction, this block will experience a force in the opposite direction. Okay, fourth question. Let's proceed with the fourth question then. It is a similar question. It's just the case of an inclined plane basically. Fourth question is, students, the incline is given an acceleration A. To keep the block stationary, this block is to be kept stationary. So the entire system is accelerated along this direction, right? Find the expression for A. Assume that the inclined surface to be frictionless. Okay, this is it. This is given to be theta. The entire system is accelerated along this direction. And this is the block. Suppose its mass is m. It's not given, but let us assume its mass to be m. As I told you, students, this block can be kept stationary with respect to the inclined plane if this inclined plane is accelerated along this direction, so that this block will experience a pseudo force along this direction. And the magnitude of that pseudo force will be given by the product of the mass of this block multiplied by the acceleration with which the entire system is being accelerated. Okay, this is the pseudo force, right? What are the other forces acting over here? One is its weight. The other one is the reaction force, which is the force exerted by the inclined plane on the block. And it always acts perpendicular to the surface of contact. So it acts perpendicular to the surface over which the body is placed, right? Okay. Here what we can do is, and force of friction is considered to be negligible. So what we can do is, resolve MA into two components. This is theta, so this will be also theta. Here of corresponding angles. This component is MA cos theta, while the other component opposite to R would be MA sin theta. Similarly, we are aware this angle is also theta. So mg can be also resolved into two components. This component would be mg cos theta, while this component would be mg sin theta. Isn't it? So the block can remain stationary with respect to the inclined plane only if the block is at equilibrium of rest. That is, it is under the influence of balanced forces. So students, for the block to remain stationary, MA cos theta must be equal to mg sin theta, and R, reaction force, it must be balancing MA sin theta plus mg cos theta. So these are the two equations. Anyway, our objective is to find A, expression for A, right, in terms of theta. So we need not to make use of equation 2. Actually, we can get the answer only through equation 1. So M get cancelled. So what do we get? A cos theta is equal to G sin theta. Make use of just equation 1. So A would be equal to G sin theta by cos theta, which is G tan theta. So theta is given. So in terms of theta, the acceleration with which the entire system needs to be accelerated is G tan theta, right? So we are over with this question as well. This is again a very simple question based on the same concepts which we are doing in the previous questions as well, right? Okay, let's proceed with the last question, fifth one. Look, this is a vehicle which is moving in a horizontal straight line from left to right with constant acceleration of 2 meters per second square. We are supposed to determine the angle which the string makes with the vertical. Okay. This is an interesting question. Fifth one. Suppose this is the vehicle. This is the vehicle under consideration, and it is accelerating from, say, left to right. It is accelerating along this direction, and it is given acceleration of 2 meters per second square. Okay, this is where a metallic bob is suspended to the roof of this vehicle with the help of a massless string, right? This is the initial position. This is the initial position. This is the initial position of the bob. But what happens is, again, if it is accelerated, then what happens is, inside it, this body will experience a pseudo force. This being a non-inertial frame of reference, and as I have stated and maintained always, pseudo force means this will experience a pseudo force which is equal to mass of the body multiplied by acceleration with which the entire system is accelerated in a direction opposite to which the system is moving. So the system is moving along this direction. So this bob will experience a force along this direction, that is ma, mass of the bob multiplied by this acceleration. So as a result of which, what happens is it will get displaced from its mean position, right? And certainly now the new position will be somewhat like this. Let us assume this to be the new position. So what I have assumed is theta to be the angle which this bob is making with the vertical. So we are supposed to find this angle theta. This angle is to be found. So due to the fictitious or the pseudo force, as it is a non-inertial frame of reference, the bob will get disturbed from its mean or equilibrium position and will certainly make some angle with respect to the vertical. And that angle which the bob or the string makes with the vertical is to be determined, right? So let me represent the forces acting over here. One is the fictitious force, which is m into a, right? The other one is its weight. It is mg. And this is tension. This is tension. Tension is the force which always acts along the length of the string towards the point of suspension, right? I'll draw the diagram over here. This is suppose the bob. This is where the force Ma acts. This is the weight of the bob, which acts in the vertically downward direction towards the center of the earth, and this is the tension. And this is angle theta. So what to do is, T being acting in the oblique direction, we can resolve the tension into two perpendicular components. So what to do is, this component, right? If this is theta, this will be also theta, being alternate interior angle. So this component is T cos theta, while this component would be T sin theta, right? Now since after getting deflected, the bob will come to rest, isn't it? So it must be under the influence of balanced forces. Therefore, students, T sin theta, it should balance Ma, while T cos theta, the component of the tension T cos theta, must balance the weight of the bob. On dividing these two, what we get is tan theta is equal to Ma divided by mg. Therefore, tan theta is equal to A by G. Right? The value of A is given to be 2 and the value of small g, let's take it 10 meter per second square. Therefore, tan theta will be equal to 2 by 10, that is 1 by 5. So the angle which this string makes to the vertical is given by tan inverse 1 by 5. So students, this is the answer. So this was a very, very interesting question. So we are over with question number 5 as well, right? So I hope after doing the theoretical concept of inertial, non-inertial frame of reference, now after doing these questions, the concepts must be much clearer than ever, right? So that's it for this particular session. Hope you have enjoyed this session, and do join me in my next lecture. I'll come up with some new concepts then, right? Till then, goodbye, and do take very good care of yourself. Have a very good day. Thank you.